Good morning, everybody. Today, really briefly, just want to talk about the 4C conference. This year, the 4C conference will be in Austin, Texas, August 18th through 20th. One of our presenters will be James Shinkle from Optical Scientific. He is our presenter for today, and he is going to be talking about the Hazmet 100. So James, take it away.
Thank you very much, Gina. Okay, everyone. So what I'm going to do is I'm going to go through why we developed Hazmet and how you can use it. And we'll kind of keep this tight. So the Hazmet 100 is basically a station for atmospheric measurement, or what they refer to as a SAM, S-A-M. Our experience, Optical Scientific, we've been dedicated to automated weather systems and intelligent meteorological sensors for over 30 years. So we are a key player in the development of NWS ASOS system. No one has more present weather sensor experience than OSI. We have over 500 million fielded sensor hours. We developed the Hazmet 100 for the U.S. Army. So they purchased 100 systems. And I'll kind of go through why that was developed for the Army and how they use it. We also developed a system called the OWI 650 present weather sensor. That was also developed for the Army. And it's a backpack style present weather sensor where they could connect it to a hazmat or a little weather station and get present weather. They use that for when they're landing helicopters behind enemy lines, stuff like that. We also developed the LoA, which is a long baseline optical anemometer with NOAA and ETL, Environmental Technology Labs. And we've developed some other sensors or adopted our sensors based on EPA requests or customer requests, so we can always tweak our instruments for measuring flow or weather. We design these to be in the field and to run unattended. So they're in the US, South America, Europe, Asia, Australia, and Africa. We have them out in the Antarctic as well. These are kind of our intellectual properties and patents. We have a lot of different patents on weather sensors. When you look at weather sensors, these are just some of the sensors that we've developed. These numbers are a little bit off. We have 1,100 airports and 2,000 highway stations around the world. It's probably more like 3,000 to 4,000 highway stations and airports. These are all the different sensors that we've built: weather identifiers, visibility, optical sensors, rain gauges, the hazmat, stuff like that. These are the sensors. These are kind of locations that we have our weather sensors in airport systems, just to give you an idea. The Hazmat portable SAM was developed for the U.S. Army and first responders. Basically, it's a rapid response system. So it's a portable station for atmospheric measurement. It was designed for use in the event of a hazardous chemical release or environmental emergency or gas attack. So they're meant to be deployed and transmitting atmospheric data within minutes. It's mounted on a moving platform. It will also transmit data showing heading, pitch and roll, ground speed, relative wind speed, and wind direction. So you can have these like out in a buoy or something if it's on the water, or if you have it on a moving platform, we have stuff developed for that. The Hazmat system comes with a carrying case. It comes with a multi-sensor, wind speed, wind direction, the control enclosure with a microprocessor, long-range spread spectrum radios, rechargeable battery. There's an optional solar panel, and then there's an optional OWI 650 present weather sensor. That's just kind of the backpack style thing I was mentioning earlier. The system features EPA's Aloha dispersion modeling program. So that's a program that was developed by EPA, and I will go into more detail on that in a minute. The line of sight range is up to 28 miles. And then this is our carrying case, and you can kind of see where all the systems are here. And then this is just the pack where the tripod fits in. Communications. So when you connect the systems, this is on the back of the box. It's meant to just set it up, put the sensors on, and then turn it on, and it'll start transmitting data. It works with EPA's Aloha Dispersion Modeling Program. So this is kind of an example of that. It basically was developed to aid in the disaster management. It generates a plot, which is easily overlaid in maps and a bunch of different mapping programs. Aloha stands for Area Locations of Hazardous Atmospheres. This is a free program that you download from EPA. And again, the Hazmet system is just the SAM, so it's the weather station that would connect to this program. So Aloha is a computer program designed to model chemical releases for emergency responders and planners. It can estimate how a toxic cloud might disperse after a chemical release, as well as for fires or explosion scenarios. It'll have threat zone estimates and a threat at a point. The threat zone is an area where the hazards such as a toxic or thermal radiation has exceeded a user specified level of concern. When you have the Hazmet with Aloha, Aloha will display up to 3 threat zones overlaid on a single picture. The red zones represent the worst hazard. The threat at the point of feature displays specific information about the hazards in locations like a school or something like that. So again, Hazmet has the spread spectrum radios. You'll turn those on. You'll be running Aloha on your computer with that other radio. And when you turn on Aloha, you'll say, add this atmospheric data, and then that will connect and start sending data and generate your scenario-specific outputs. So that'll include the threat zone pictures, threats at specific locations or strength graphs. It calculates quickly chemicals that are escaping from tanks or puddles or gas pipelines and predicts how those releases rate of changes over time. The models are easily released scenarios, toxic gas clouds, boiling liquid, expanded vapor explosions, jet fires, vapor cloud explosions. It has all of these models developed by EPA in the program. And again, it's easy, it's free for you to download. I'll send you the link. It designed to produce reasonable results quickly. There's calculations that represent compromise between accuracy and speed. All of them were developed quickly to assist the responders, so it minimized data entry errors and stuff like that. And it has a chemical library, so you can add all this stuff in there. So this is, again, a free program that you can link the Hazmet system to. So Hazmet, again, is just a portable weather station or station for atmospheric measurement that you would use so you could go out, deploy in the field, turn it on, get your guys out of there, and then use this Aloha program from EPA. And then that would help you do the plots and dispersion modeling. And that's a free program, and we just give you the weather station. If you need something more advanced or you want a permanent system, a standalone system, we do provide unattended field operation modular automated weather observation systems, or what we call MAWAS. We have a low-powered weather stations available. We have the Hazmet portable system. We have a thing called long base line optical anemometers if you're looking like along a fence line or want to understand a larger area or larger wind. These are some of the examples of kind of a MAWAS system. It's designed in the factory to be easily configured to add other sensors. This is kind of an example of a weather system at an airport. So you can do that, but we can make changes if you want to bring in other sensors. It all goes into a data collection unit. We call it a DCU. This 432 is kind of lowers the overall cost and makes it easier for installation. So we can create weather stations and then transmit that data to another program that you use or you build, or we can create a program for you. So if you want us to create a program for you for weather stations, we can do all kinds of different workstations, forecaster workstations, ATC workstations, maintenance. Some of the stuff is for airports, but it'll give you an idea of the capability of what OSI can offer, at least on the weather side of things. If you want to do weathered network systems and create like a little weather system around your facility, we can put a number of different sensors around your facility or around a process to kind of help you better understand that and work with you to develop that. Some of the typical sensors that you might see in a MAWA system are just these ultrasonic winds, barometric pressure. We have a visibility and present weather sensor and ambient light, but you probably don't need a lot of that for EPA. This is another sensor that we built, the 430, which is basically runway visibility. Another sensor that we built was the 432 MAWA. So you can configure, if you look at this, you can configure you can plug in weather sensors into a present weather system and kind of make it less expensive if you want to add present weather. A lot of people are not necessarily interested in that, but that's something that we can always add and make the system less expensive. We have a low power automated system weather station that we've developed. We have what we call the APG 815, which is a all precipitation gauge. We have present weather and visibility sensors. These are optical rain gauges out on stuff. So we have all these weather systems all over. We have a helmet, hail sensor. If you go with like the APG 815 and you want to include present weather with wind speed, wind direction, to see if maybe the weather contributes or lessens the amount of pollution, we could definitely design a system around that where you can add sensors into that. LoA is a long baseline optical anemometer. That can be used to measure crosswinds along a fence line. This is a system we did for NASA where they were checking wake vortex. It was developed, LoA Technology was developed by Environmental Technology Research Labs and NOAA. It measures the crosswind across the optical beam crosswind and then the turbulence over that beam. So it's going to be more accurate than like a single hazmat or a single weather station. So if you're looking to kind of better understand what's happening around your facility or along a path line, we can help you with that. The different ways you can use an LoA is you can use a single path LoA that measures the crosswind across that open path up to 10 kilometers. And this kind of explains if you use a single path because it's measuring bidirectional. If you want to make it like a giant anemometer, so to speak, you can add two sensors and try to get them 90 degrees apart. We have algorithms where we can kind of change that. So if you have it at a different degrees, if you can't get true 90, we can set that up. And that'll give you a better ratio of what's happening, or you can look at the magnitude of the wind over that larger area. You can surround an area of concern with LoA, so you can add a bunch of those. So we're pretty flexible with what we can do. The Aloha program, which I had mentioned earlier, this link right here will take you to that program where you can download it for free. And if you have that program and you need a weather station, we can either do a permanent or a hazmat that you can use as a portable system to kind of move around. So this is a free program, and that's the link to it. So that's about it. We try to keep it kind of tight and quick. And, again, the hazmat is just a portable weather station that's meant to be deployed quickly, and it will give you the atmospheric data that you can then bring into a program that will help you plot your any releases. So that's how that is set up. Okay, does anyone have any questions? Gina, maybe?
I'm sorry, I don't have any questions, but John might. John Wigger is on.
Oh, great. Hi, John.
If not, John can play a little bit of his guitar for us. John, do you have any questions for James?
He may be muted.
He is muted. Well, I guess that I'll take that as a no, but James, I want to say thank you so much for doing this webinar for us today. We will post it on our 4C website and the 4C YouTube channel. We look forward to seeing you at 4C in person, August 18th through 20th at the Hilton downtown. And if you have any questions or want to get some more information after watching this off the website, please feel free to email James Shinkle or email us and we can get you in contact with James. Thank you so much, and we appreciate your presentation.
Yeah, thank you for having me.